Welcome to section 9.2, adding and subtracting and multiplying radical expressions. So remember when we were to take 2x plus 5x, we can add these because they're like terms, right? And we do the operation on the coefficients and we would get 7x. So now it's going to be really similar, except instead of x, we're going to have the square root of x, and we're going to treat it the same way. It's going to be 7 plus the square root of x. So when we add and subtract, just as with our polynomial equations, adding and subtracting is just combining like terms. Like terms. All right, and like terms is same index, and same radicand. Okay, so not that bad. But let's look at this example. They want us to add 12b plus 75, square root of 12b plus root 75b, and our radicands are definitely different, right? So our first step is to always simplify completely. Okay, so let's simplify first. So we're taking the square root, so we're looking for perfect squares. So we can take this intermediate step and write 12 in terms of a product of a perfect square, and we can rewrite 75 as the product of the perfect square. And now the square root of 4 is 2, left with the root 3b. Square root of 25 is 5, root 3b. All right, and then here are our like terms. Index 2, same radicand. So we are going to combine the coefficients. And 2 plus 5 is 7, square root of 3b. All right, so let's try some on your own. Go ahead and push pause, and then come back and see how you do. All right, this first one's pretty straightforward. You don't have to do any simplifying. So 2 minus 5 is negative 3. Here, we still don't have to simplify. All of our radicands are completely simplified. So we just have to search for the like terms. I'm going to cross off as I go. 5 minus 9 is negative 4. And then the root x are like terms. Negative 7 plus 5 is negative 2. And then the cube root of x. And number 3, we finally have to simplify. So we're taking cubed roots. So if you want to take this intermediate step and separate out your radicals, please do. All right, so something like this, separating out the cubed roots. All right, and then the cubed root of 27 is 3. Let's see, x to the 5th, if you wanted to do a little bit of work, it'd be x cubed times x squared. And now the cubed root of x cubed is x. And we're left with the cubed root of x squared. All right, let's keep going. Cubed root of 8 is 2. I'm going to write it first, x. And then the cubed root of x squared is already simplified. Exponent is smaller than the index, no common factors. All right, this is our like term. We have an x, and we have same index, same radicand. And 3 minus 2 is 1, so we can just write x cubed root of x squared. And that's that. Okay, let's consider multiplication next. So multiplication, we're going to use this rule that we derived earlier for our exponent rules. So again, we can prove this by looking at the corresponding exponents. So the nth root of n is a to the n. The nth root of b is 1 over n. And then we can use a backwards multiplication rule. And then rewrite it as an exponent. Okay, so the moral of the story is when we have the same index, we can multiply the radicands. So for instance, this expression, we can look at 2 times 3. And then the next one, we have the same index. So we can combine the radicands underneath the same radical sign. And we get 6 cubed root of x squared. All right, and then this one's a little bit different. Here we have square root of x times square root of x. Well, root x times root x is just x. And if you wanted to do that intermediate step, we can do this. X times x is x squared. Square root of x squared is x. Okay, so in general, that was an x squared, or excuse me, a square root of x squared. Like this. So in general, if we have an nth root and we take it to the nth power, it's just going to be x. All right. Now we have something a little bit more complicated. We're going to be multiplying out our essentially binomials, and we're going to do it the same way we would do polynomials. We're going to FOIL. So let's do the first one together, and then you guys can try some on your own. So we would do our first terms. Outside, inside, and last. So let's see. Simplifying, 3 times 3 is 9. 3 times 3 is 9. And again, root a times root a is a. Next, same index, so we can combine AB under the same radical sign. And we can do that for these two. All right, and then negative 3 root b times root b is b. So altogether we have 9a plus 6 square root of ab minus 3b. So let's go ahead and push pause, and you guys can try these 3 on your own and then come back and check your solutions. All right, so here are our solutions. Go ahead and check them over. You can push pause to work your way through. This last one, I used our formula for squaring a binomial. And then if we simplified that out, we would get this. Let's see. So 2 times 3 is 6, times 2 is 12 root x, and then plus 4. And there you go.